Today we're going to take a look at a review of functions and properties of functions. So first, taking a look at what a function is. A function is basically a relationship or a relation between numbers where each input, by the way, an input is often thought of as the domain, or often we use x values. A relation where each input has at most one output. And those outputs are often called the range, and we often use the y values for that. Basically, the answer is always the same when you ask the question over and over again. Now, if you took Math 99 from me or Math 98 from me, you probably heard me talk about this thing called the function machine, labeled f of x. And things go in on the left side and come out on the right side. So we could dump the number 3 in, and maybe the number 5 comes out. Now, what the function does to it, we don't really know. Maybe it adds 2, maybe it squares it and subtracts 4. It doesn't matter. The point is, when 3 goes in, 5 comes out. And so if I were to come back and throw 3 into the function again, we would again get 5 out again, because this input value has only one possible out value. When 3 goes in, the only possible answer is 5. Now, that's not to say if I change the number to maybe -7, I might get -1 out of the function machine. So different numbers can give different values. But if I stick the same number in twice, I cannot get 2 different answers. That makes it not a function. So maybe kind of visually looking at this with a picture, we'll have some big domain, which I'll represent in blue here, the domain or the inputs of the x values. Maybe they're the numbers 1, 2, and 3. And they are going to be mapped by this function over here to these output range values, maybe the values of 1 and 2. And maybe 1 maps to 1, 2 maps to 2, and maybe 3 maps to 1. What I notice is that every single value gets mapped to only one place. Each input in the domain goes to only one possible value in the range. Now, 2 different domain values can go to the same range value, and we saw that with 2 people going to 1. That's okay. The point is, 3 always goes to 1. It doesn't have some alternate option. So this is an example of a function. Everybody gets mapped to one place. We could contrast that with this domain. Maybe it's got 1 and 2 in it. And how about this range? It's got the numbers 1, 2, and 3 in it. And let's say 1 maps to 2, 2 maps to 1, but 2 also gets mapped to 3. Notice the 2, the input value, is going 2 different directions. That's not allowed with functions. So we say that is not a function, because each input can only have one possible answer on the right in the range. Now, same idea. Some people really don't like the picture. Some people prefer a table of values. And so if I have a table of values, some x and y values, x is typically my input value, y is typically my y output value. So if x is -2, y is 3. If x is 7, y is 4. If x is 0, y is 9. Notice each x has one unique y value with it. And that is because this is a function. As far as we know, no value has 2 different possible y values with it. Now contrast that with this table, where I say maybe 7 maps to 0 and -4 maps to 3.5 and 7 maps to 2. Notice the problem here is 7 Let me highlight it instead of circle it. 7 is inputted twice, but it gave us 2 different answers. To be a function, you can only have one possible answer for an input. So this is not a function. And this decision is really easy to make if I've got some type of graph. Let's consider 2 graphs. First, let's look at this graph here. I'll draw the graph here in blue. A graph is just a picture of solutions. Actually, I'm going to draw a graph like this. Kind of loopy. And what makes a graph a function is each input, or each x value, has at most one y value. So I'm going to draw on here a line. Let's see, what color do I want to make this line? Let's make this line red, just for discussion. So I'm going to draw on here a straight line. And I want to notice as I move this line across the graph, it only hits that blue graph one time. This red line represents an input value. Wherever the line is, that's the input. And notice the graph, it hits once. Only one possible output value. We call that the vertical line test. A vertical line is going to cross the graph no more than once. That makes it a function. Function. Because each input has one output. Each vertical line only hits the graph once. Now contrast this with this other graph that I'm going to draw here. Let's say a graph looks like this. Notice now if I take that vertical line, and it seems to hit the graph once, uh-oh. Notice when I draw a vertical line here, we cross the graph 1, 2, 3 times. There's 3 different outputs for that input value. That is not okay, so that makes this one not a function. So it's pretty easy to identify a graph, a picture, or a table if it's a function or not. We're just trying to see, is there some point that has 2 output values for 1 input value? It might be a little bit more tricky to do it with an equation, but it's still possible. Let's consider the equation x plus 2y equals 7. Now remember, x is the input, y is the output. So let's find out what y equals. We're going to solve this equation for y. We can do that by subtracting x. 2y equals negative x plus 7. Divide by 2. So y equals negative x plus 7 over 2. And I can see from this equation that if I pick a value for x and plug it in, I'm always going to get the same answer. For example, if I put in 3, negative 3 plus 7 is 4, divided by 2 is 2. And now if I stick that number in again, I'm going to get the same answer again every time. There's only one possible answer. This is a function. If I pick a value for x, there's only one possible answer for y. Contrast that with x squared plus y squared equals 16. Still, y is our output variable, so we want to know what y equals. So we solve by subtracting x squared from both sides. Y squared equals 16 minus x squared. And then we take the square root of both sides to get rid of the exponent. What we have to remember, though, is when we take the square root of both sides, we have to consider plus or minus the square root of 16 minus x squared. Notice y could be either positive or negative. Y has 2 options for a given value of x. Because of that plus or minus, there's 2 options. This is not a function. So that's kind of 5 different ways to look at a function, define a function. One input, each input has exactly one output. So you can think about the function machine, the picture, the table, the graph, the equation. Doesn't matter. Each input has to have one output. These inputs and outputs in a function we call the domain and the range. So let's look at domain and range real quick. That's supposed to be a B. Looks awful. There we go. It's a better B. First, let's define domain. Domain, that's the inputs. All possible inputs might be a better way to say it. Usually that means the x values, but the domain could be t for time or whatever's being put into the functions. Tomorrow we're going to see even y can be an input if z is the output. We'll save that for tomorrow. The range, I'll keep it on the same bullet point. Range is all possible outputs. Often thought of as the y value. Sometimes it'd be the velocity, depending on the context. But the outputs, the result of the function. So if we were to look at a graph, let's make this a subpoint. If we were to look at a graph, let's see. We'll go 3 to the left, 2 to the right, 2 up, and 1 down. And I'm going to put a point at -3, comma 2. I'm going to put a point at -1, comma -1, and put a point at 1, comma 2 here. And I'm going to kind of draw this guy, curve around between those points. To find the domain, that is all the possible x values. Another way of saying that is if we were to take this graph and we were to squish it down onto the x-axis, all the way across, what x values would be included in that squishing? If we were to squish it down onto the x-axis, you see it would kind of fill in everything. Whoops. Didn't want that. It would kind of fill in everything between x equaling -3 and x equaling 2. So we say the domain is x is between, and it includes, because we have closed dots, -3 and +2. For the range, we go the other direction. I'll come in a different color. Range, we take the graph and we say, hey, if we squeeze the graph onto the y-axis, what y's would be covered? So notice if we squeeze the graph onto the y-axis, we end up covering everything between -1 and 2. And we actually equal those values. So the range y, we say, is between -1 and 2. Let's do one more. Let's say the graph goes, whoops, let's make it blue. Let's say the graph goes like this. I'm going to put arrows on the end to say it keeps going that direction. But then, at 1, 2, I'm going to put a hole in the graph. So that's a spot where the graph is missing a piece, right at that point. For the domain, again, we're squeezing the graph down onto the x-axis, maybe up, depending on the direction. But notice the arrows on the end say the graph is going to keep going, except don't forget about that hole at 1. Pretty much we include all of the x's except for that hole. There's no value there at 1, so we do not count that. So we would say x is smaller than 1, or x is bigger than 1. But notice it's not equal to because we've got the open circle there at 1. You could even do this in interval notation if you wanted to, going from -infinity, 1 with a curved bracket, union for the or, and then 1 to infinity. For the range, we close the graph in on the y-axis. And here we're going to be tricky. Notice on the left side has a hole at 2. But the right side does have a value at 2 that comes in. So there is a value at 2 coming from the right side. It doesn't have to be there twice. It just has to be there once. Every single y value above 0 seems to be valid. So we're going to say y is greater than or equal to, because it does hit 0. And if you want to do that in interval notation, it would be a square bracket at 0 up to infinity. So with the graph to find domain and range, all possible inputs and outputs, we will squeeze the graph in on either the x or y axis and see what values are covered and what values are not. With functions, expressions and equations, it's going to be a little bit more difficult to find the domain because we have to ask ourselves what doesn't work. There are a couple things that we're not allowed to do with functions that we've seen before. Some we haven't seen yet, and we'll get to those later in this course. But for now, the two big ones that we've seen is when we take the square root of some stuff. That stuff, we cannot take the square root of a negative. That stuff has to be greater than or equal to 0. Because if it's less than 0, we cannot take the square root of a negative number. The other thing we've seen is fractions, where we take some numerator divided by a denominator. With fractions, what's not allowed to happen is that the denominator cannot be equal to 0. If we divide by 0, the function's undefined, and we can't do that. So for example, if we have 3 over x squared minus 9, what can't happen here is the denominator of the fraction cannot equal 0. So if we want to factor this denominator, x squared minus 9, that's easy, x plus 3, x minus 3, that cannot be equal to 0. Well, that happens when x is equal to 3 and negative 3. So we're going to say x cannot be equal to 3 and cannot be equal to negative 3. That is our domain. Because if it was 3 or negative 3, we would have 0 in the denominator. How about this one, the square root of 2x minus 7? With the square root, we know the stuff under a square root has to be greater than or equal to 0. We don't really care about the square root, but if we add 7, we get 2x is greater than or equal to 7. Divide by 2. X has to be greater than or equal to 7/2. And that's our domain. Because if x was smaller than 7/2, we'd be taking the square root of a negative number. How about this one? The absolute value of 3x minus 4x squared. With this function, we're really not limited by anything. There's no rules about multiplication or squaring or absolute value where we say we can't take the absolute value of this stuff. We can't square these type of numbers. We can do all those operations with everything here, every number. So here we say all real numbers. Sometimes people use this funky capital R to represent all real numbers, meaning that the domain, any number can be stuck in for x and will never ever be undefined. Okay, so that's 20 minutes of background information on functions. The big important thing that we need to be able to do with a function is to evaluate a function. The idea is we have this notation f of x, which you remember does not mean f times x. We'll never split these up. Do not divide by x to get f alone. No, we can't do that. That's f of x, meaning the function f has the variable x inside of it. And that, whatever is in the parentheses here, whatever's in the x, we replace the variable. With this. Whatever's inside the parentheses, the variable is going to become. So for example, if I've got the function f of x equals 3x minus 4, and I'm asked to find f of 7. Notice the 7 is inside the parentheses, so the 7 is going to replace the variable. Whoops, wrong color. So we have 3 times x, which is now 7. Notice when we replace it, it goes into parentheses, minus 4. Well, that's pretty easy to simplify. 3 times 7 is 21 minus 4, and 21 minus 4 is 17. So f of 7 is equal to 17. And we can do this with any old number. We can find f of negative 2. And again, negative 2 is inside the parentheses, so negative 2 goes into the x. It's 3 times the negative 2 minus 4. And then simplify. 3 times negative 2 is negative 6 minus 4, and then when we subtract, negative 6 minus 4 is negative 10. Now we can make this more interesting if we would like. We could take f of x plus h. Notice now in parentheses we've got this whole x plus 8 expression. So that entire x plus h is going to replace the variable. Instead of 3x, it's now going to become 3x plus h. It replaces the variable, minus 4. And then we can simplify by distributing, so we have 3x plus 3h minus 4. How about this one? This is one that gets people a lot. Let's tweak it a little bit. F of x plus h, and then I'm going to subtract f of x. Well, first we're going to put x plus h into the function. Then we're going to put x into the function. Now it's off my screen, but I hope you have it in your notes. F of x is 3x minus 4. So now f of x plus h is 3 times x plus h minus 4. And then we subtract, and it's important to notice we're not just subtracting the first part, we're subtracting the entire f of x. If I just write 3x minus 4, the subtraction is only going to be on the 3. So to make sure we subtract the whole thing, the entire function, I'm going to put that function in parentheses. This is going to be a very important idea as we work through this course. f of x to subtract the entire function, put the entire function in parentheses. And now distribute. So we'll distribute the negative, we'll distribute the 3. We got 3x plus 3h minus 4. Distribute the negative is minus 3x, and a negative 4 is a positive 4. That's the piece people miss when they forget to distribute the negative. Someone's going to do that on the test. Don't let that be you. Well, now we can simplify. 3x minus 3x is 0. Negative 4 plus 4 is 0. All that we're left with is 3h. Let's try another example. Example number 2 here, we're going to consider the function f of x equals x squared plus 3. And we'll start with a number to break us in. Let's find f of 2. So notice we've got 2 in the parentheses. 2 is going to replace the variable. Actually, let's make it a little more interesting. Let's do f of negative 2. So we've got negative 2 in the parentheses, so negative 2 is going to replace the x. Negative 2 squared plus 3. Well, a negative squared, that's a positive 4 plus 3, and so the final answer is 7. We could find what is f of a. You've got a in the parentheses. That's what's going to replace the variable. X squared is now a squared plus 3. Well, a squared is just a squared plus 3. There's really no simplifying we can do to this guy. So let's see if we can do a little more challenging one, what I think is going to be a really great problem. Let's do f of x plus h minus f of x, and we'll put the whole thing over h, and see how this simplifies. Again, at first we've got the x plus h in parentheses. So that's going to be x squared is now x plus h squared plus 3. Then we subtract, and notice we subtract the entire f of x. To subtract the entire f of x, we're going to put it in parentheses, x squared plus 3. And then we'll put the whole thing over h. Let's see if there's any simplifying we can do. We can square this x plus h squared. But I want to be careful of something as we square x plus h squared. Don't want people to think I only pick on kitties. Every time you do this, a puppy's going to die. If you have an exponent outside of parentheses, I see people try this all the time. They try to distribute the exponent. So in this example, they would get x to the 4th plus 9. That's wrong! No killing puppies. You can't do that. Because you've got to consider that we're multiplying x squared plus 3 times x squared plus 3. And so if you remember how to do that, we do multiply, we do square the x, but then we have to multiply them together, xh and xh. It's there twice. It's plus 2xh plus h squared. And if you don't remember that shortcut, think x plus h times x plus h, and then multiply it out. Then there's a plus 3. Distribute the negative, negative x squared, negative 3, all over h. So now to simplify, we've got x squared minus x squared. That's 0. It's kind of cool. There's a 2xh term. There's an h squared term. Plus 3 minus 3, that's 0, all over h. Now, we all remember we cannot just cross off an H. That kills a kitten. We just avoided killing a puppy. Don't kill a kitten. Instead, what we're going to do is we have to first, to reduce this fraction, factor out the GCF of h. 2x plus h all over h. And now that the h is multiplied, it's a factor. Now we can cross it out. And that's going to leave us with our final answer of 2x plus h. So that's your quick review, introduction of functions. Whatever's in the parentheses gets plugged into the function and then simplify what you have. Domain is your input, range is your output. And a function, for every input, there is at most one output. Take a look at the homework, come to class tomorrow with questions, and I'll see you then.